Which meeting is this?
Hello.
Hey, how you doing, man?
Good.
That's good. Yeah, usually when I send the you went on the one from the other day, I think.
Ah,
Yeah. Usually I send it like I try to recreate the meetings every time. So yeah, like it's usually different every time. Okay. Um, I sent you this. Did you had a chance to look at it? Maybe it's more effective if you do it, or did you want me to just like talk about it?
I looked at it for a minute
Okay.
and I had to go.
Okay. Did you wanna? Are you in front of like do you have our studio right now?
Um, I can pull it up real fast.
Okay. Did you wanna maybe like do it? You know, I could probably guide you. It's more effective if you try to do the coding because like I think this class is like a lot of it is coding. So
Yeah.
okay, let me stop sharing.
Let me pull it up real quick.
So this one was it wasn't bad. It was just there was a few besides the mishap from getting the data frame or the database. That one was actually I just needed the name the original name of the data.
Ah,
Yeah, I think that's every time. Like if your school always hides it, I just need that original name.
hmm. All right.
All right. Okay. Okay.
I'm actually gonna pull up.
Yeah. Let's maybe we can like look at the one I have and then just look at the questions.
Um,
Okay, there you go.
There we go. I'm gonna just put this over here so that the code's still up.
Yeah, I mean, for the one this one, like I think I'll do it again the same way. Like I'm actually gonna write the questions. Like I did it for this one. I wrote the questions inside the code.
So you did this, and you copied and pasted the questions in there.
Yeah, it's a lot of people they do that. It's just I didn't have time, but this time I had a little, like massive amount of time. So I had like the question and then the answer.
Okay. You want me to do that for each question?
It's up to you. Did you want to like base it off what I have already?
Yeah.
This one's gonna take a long time. That's like if we went like one by one. It's
Oh
like
yeah.
it's like it's more than 8 questions because there's like 2 parts.
I guess we can just do a little bit of it, and then.
Okay. Did you want to just like maybe open like pull up my file and then we'll just go through it.
Okay. Here, I'll stop sharing. And then.
You have my file, right?
Yeah. Wait, hold on. I see what you're saying.
Yeah. I think it's more effective if you actually because like if I just talk about it, there's like there's less traction of the code. Oh, yeah, there you go. That's the one. Awesome. Okay. So yeah, like I guess we can start with we already answered which ones? We had like 1A.
One. Hold on.
I think we had I actually redid this. Let's just start from one. We might have to I think because I think the answer we had in the beginning after taking a looking at it wasn't correct.
These.
Yeah, like let's look at like 1A. I think we had something like 100, right? I think try running this one and see what you get.
This one.
Yeah. Oh, run the other ones first. Okay.
It's set.
And then that one, yeah. 13 and 14. Yeah, so this is the actual answer.
So, how many dogs?
Adult dogs, yeah.
One. 226.
Mm-hmm. What did we have before? I remember it was like
170.
something. Yeah. The way, so like, I had time to actually like make the code more efficient. So if you take a look at this, for both cats and dogs, I'm using a which command. It's kind of similar, but we kind of broke it down. Like if you remember, we broke it down to like we had the cats one, right, only, or like dogs, and then we made it like, oh, what are the number or which cats are older than 1 year old, or like 1 year old or older. So
Okay.
I think that's why it wasn't the same number. But anyways, yeah, that's how you code that one. Okay,
I think we got number 2 correct.
we have that one. Okay, good. So I guess we can move on that one.
Yeah. Problem 3. So, you want to explain what you did, and then.
Okay, so the question here is like, so the measure of the center, like, do you know what that kind of? I mean, do you have like a feeling of what that means? Measure of center.
Kind of.
Yeah, like the bell-shaped curve, like normal distribute. In the middle,
Yeah.
what value is that in the middle? If you remember.
I'm blanking out. Can you remind me?
Okay. So like for no, for a bell-shaped curve normal distribution, you know how like there's like two parameters that's very important. The which one of those are those? Those are the mean and standard deviation, right?
Hold on.
Okay.
Yes.
And then what does the where is the mean in the bell-shaped curve?
It's like it's the Q1 spot, right?
What is that?
Q1 spot.
Yeah, it's technically yeah, it's in one spot, but it's where is the middle, right?
Okay, yeah.
Yeah, so this is just confusing you. This question is meant to test if you know what it is, but it's synonymous. When you're saying measure of like center, like at the center, it just means that it's the mean. The measure of center is the mean.
We had one of the problem 3B on our lab today.
Oh, you guys have that? Okay, that's good. Yeah, and then pretty much just 3B is like average. Like we're just asking for average. It's obviously the mean. So that's it. Like you get the average of the mean.
So if we run it,
Cat, wait. Oh yeah, you have to run the other ones first. Yeah, that should work now. Oh, I didn't visualize it. Try putting it down at the bottom, like so. Enter. No, don't delete it. Yeah, go back and then not hide.
go back.
Control Z, and then like yeah, the next line just put in print cat mean, like yeah, print and then cat mean. Yeah.
Do we need this?
I don't think not for this one. It's just a number. Okay.
And then it's gonna ask for the average cat.
So yeah, that's the average adult cat, and then the next one.
Hmm. Why did you use this?
Okay, so it's like one of those things that every code, I think Python even has round. It says that round to one decimal place.
Mm-hmm.
So that's why when you do round, it just rounds it. The one thing that's important about this is you know where it says digits.
Yeah.
So like you could technically put just a number, but I found out that for this one it doesn't matter. It'll give you 8.6, whether you put with digits or without the word digits, actual word digits. And then for the standard deviation though, if you only put like did 2 and not digits equals 2, it rounds it to like 2, not 1.91. So that's why if you're gonna write R coding like this for a round command, make sure you put in digits equals and then whatever number you have after is the amount of decimal places you're gonna round to.
Okay.
Okay.
Wait, what's 3A? Did we miss
That is that part of the question or is that not part of the question?
control?
I forgot if that was part.
Hold on. What in the world just happened?
Let me see.
I can just copy and paste the code. Yeah, 3A isn't on there. Isn't showing up.
It says like which measure of center, yeah. I think it's just a word.
Oh, it's just a word.
Just a word, yeah.
Ah, oh, I see the ANS. stuff.
Yep.
Okay.
Okay, let's look at this next one.
Problem 4. So why did you explain what you did, and then I'll comment.
Okay. So I said, like, for a normal distribution, there's two measurements, right? There's the mean and standard deviation, right?
Yeah.
So we know now that the measure center, the middle of a normal distribution is the mean. That's the measure of it. But then what is the standard deviation? So standard deviation is the measure of spread. You probably heard of this, right?
Yes.
So standard deviation measures spread. This is how far away you are from the mean. So like, you have this like bell-shaped curve that's like peaked at the mean, and then it kind of like tapers down like on the sides. And that's like the spread of it. So when you're saying here that what is the measurement? So that's what it is. It's a standard deviation. Uh, and then how you do that is with the SD instead of like mean command.
Okay. Because SD stands for standard deviation.
Yeah. That's the one thing I don't like. I mean, it's good, bad at the same time. Like, there's a lot of cryptic things in R that, like, oh, that's what that means. But you'll get used to it eventually. Oh yeah, and you have to visualize this one. You gotta do the print again.
Oh, print.
Yeah. So when you do the comma, do you know when to do that and when not to do that?
No.
Okay. So when you do a comma, it's technically when it's like a matrix or like a vector. Like you have like a data frame, but then this is just a number. This is just a number, right?
Yeah.
So if it's just a number, when you print it, that's it. There's no comma.
Got you.
Okay. Okay. This next one is a little difficult to explain, but all right. Are you done with 4? Okay.
We got number 4. We did number 4.
Okay. So 5. Do you know what a z-score is?
Yes.
Okay. Uh, what's the like this is just pretty much calculating it, right? Like this is what I have here in 45.
So you're just basically calculating z-score.
Yeah. I'll tell you why, because the thing is with R, there's actually no function built in that calculates z-score. So you just have to like manually do it or create a function, but you can just there's no point. It takes too long. So you could just manually input the equation in here.
So is that why that one's confusing? Because there is no actual identification for z-score.
Yeah, I don't know why. It seems like R is like one of the, and that's it's a statistics program, for the most part. But like I don't know why they have a t-score. You can get a t-score.
In
But like
statistics.
yeah, but z-score apparently there is no built-in.
That's weird.
I know, right? But yeah, this is how the equation is pretty much direct from this, and then that's the answer.
She taught us how to calculate it manually, but not like.
Yeah, for the most part, like all those equations, like doing standard deviation and like the mean,
Yeah.
you can manually. I think that is very helpful. Gives you more insight. Like why don't you just like for this one, like the z-score equation, you don't need a built-in program to like do it for you. Like a lot of programmers, they tend to like use like or let me say that like a lot of amateurs, you tend to use the built-in programs, but once you get to like a hang of like actually knowing the first principles, the equations, then you can what's hindering you from actually like making your own command, right? So but at the same time, it's always easier just to use someone else's code.
You know how to do it, of course.
Yeah. But yeah, that's really like in the beginning you learn like using mean and SD. Those are built-in commands. You could use those, but it's like a black box. But if you know the equation, at least like you have some confidence that it's the right one. Okay.
Let me read.
Oh, I forgot to. Yeah, the answer is on the right on this one.
Um. So could you technically figure this one out in your head, or is it easier to do in R?
Which one?
Number 6.
Um, so like this one, you need to look at some like graph, like maybe a histogram. I think would be the best one. Because you know, once you look at this histogram, right? Like, and it's asking you which of these you know, it's asking you the location of a 13-pound adult cat. So 13-pound. So where's the mean here? The mean is, what did we figure the mean was? It was 8.6, right?
The mean for what?
For cat weight. It's 8.6, right?
Yeah.
So if you look at this histogram, that's what we have, right? It's 8.6 is the peak value.
Yes.
And then so what this question is asking you is like, can you describe, and there's like a few things there like about standard deviation, and then just look at it. You could technically think about this and then not like output a histogram, but looking at a histogram is clear because then you just go to 13. So 13 in the, you know, at the bottom, and you compare that to 8.6, the peak. How far away are you, right? And then you usually when you're saying how far away you are from the mean, what's the measurement of that?
It's either negative or positive.
Standard deviation, right?
Mhm.
So like when you're saying how far away you are, positive standard deviation, you just look at your standard deviation. What was it? 1.91. And you kind of assess how far away is 13 from 8.6. How many 1.91s do you have? And that's the z-score. The z-score tells you how far away you are. And what was the z-score? 2.3, right?
Yeah, positive.
So 2.3 stands for 2.3 standard deviations away from the mean.
So that question before also helped us answer.
You got it, yeah. Yep. So it's kind of like, I mean, these questions are nice because they lead you to something. I think they don't skip, but there's some like 8 maybe that's look different. But yeah, that's the answer. The more than 2 standard.
Oh, I put approximately on accident. Okay, that could have been catastrophic.
Okay.
Uh, Number 7. You,
All right, let's take a look at this. So let me see. What portion of adult cats weigh more than 13 pounds? You
is this
define.
what I highlighted, or
Yeah,
did you?
what this is built in. This is pretty much just the normal distribution, like command.
Okay.
And then like what it takes in is so like, let me say like so what it takes in is like, you know, when you're doing the standard you know, normal distribution, you have an x, right? That's what you want to get at, the x. So the x here is your 13.
And then your y is your 3, or your y is your 1.
Yeah. And then like your mean obviously is the other term that you need for to describe the normal distribution. And then you also have the standard deviation. So that's the arguments: 13, mean, and standard deviation. And then why are you doing 1 minus is because you're wanting to get the lower tail. You could have done it another way, uh, but like if you just do p norm, it gives you like the right end, like the higher value. But you want to get the lower value, so the lower tail, not the right tail. So that's why you're doing 1 minus in this one. So like 1 minus means like what portion of the cats weigh more than 13?
Got it.
This one is like one of the like, so like if for to like, I guess a takeaway would be you know, learning how to do like what a z-score is, and then what how to do a mean and a standard, and then also p norm. P norm is a command that's like important to know.
Why would you use digits here?
Um, this one didn't ask you to do it in three. Every time you do that one, it's like significant digits or significant figures. So I think this one is let me see. Yeah, it says report to 3 decimal places. Yeah.
So you use the round command. Okay, I see the round command
Yeah. Every time you see the digits, it's usually associated with the round.
Okay, that makes sense.
Cool. And then this last part is these are fun because they're actually did your teacher talk about the what these are, the quartiles?
Say it again.
The quartiles?
Yes, they've talked about inner quartiles.
What are they?
They're like, it's like the box plot idea.
Yes, yes, yeah. You got it, yeah. The box plot is like the graphical representation of the quartiles, right?
Yes.
Yeah. It gives you like where they are, 25, 50, which is and 50 is the what? The mean, right?
Yes.
And then you have the 75, and then there's like five different numbers, right? There's it starts off with the min, 25, 50 or the mean,
Yeah,
75.
like minimum, the Q1, mean,
Yeah.
Q, the maximum.
Yep. So like now what's the command for that in R? And so this is that command, five numbers.
So
It's really cryptic. That's why one of those like, oh, that's what the five num means. Five num means that like calculating the quartile in R.
okay, cool.
Okay, try writing that one. Five num.
5 num.
Yeah, let's see what it says.
Oh wait, we
Oh,
got it.
oh, because we didn't define it up top. I think we just did cats. This is somewhere there. There you go.
There we go.
So, what's this question asking? So what quartok would contain a 13-pound dog? So, which one is it?
What quartile would contain 13 pounds? 13.50.
Yeah. What are the selections there? I couldn't remember what they were.
Fourth, third, second, first. So it'd
Yeah, it
be
has to be the second.
yeah,
Yeah.
the position of the answers.
Try see if it says fourth, third, second, first. Shouldn't it be first?
It should be second
Why is it second?
because it's third.
25, 50, 75, and then 100, right?
Yeah.
So like the first isn't it 25?
Well, the first is the minimum. They're asking for a 13-pound dog,
Okay.
and then so the second one fits in the. Oh wait, so you're saying it should be that because 13 is not 13.50, but it's in between 33.30 and 13.50.
So is there a fifth quartile? Like I guess my question is there like a fifth quartile?
No, there's first, second, third, and fourth.
Okay, but then like so the first one, what number is that in the five now?
3.30 is the first one
But
because
what
that's
about
I,
okay,
I see 3.1 as the minimum and 131 as the maximum. I see
okay.
4 as Q3. This is Q 13.50 as Q1, and that is the median.
Mean meaning the 50, right? Mean meaning the 50%.
Yes, yeah.
But then 50 was it? So as I remember it, the first is always 25. Just try it though. Like it's up to you if you want to try it. Like so okay, the you could put second, you say second.
I'll go with first, but I believe it's second.
Okay, go ahead. I mean you have two tries, so we'll see.
You might be right.
All right.
So we got
Um,
number 2 wrong. Is the one we got wrong.
which one?
Number 2.
What about 8B? You got that one right?
Okay, you got it. Screw you. You're right.
What happened?
You're right. It was 1, the first one.
Okay. Wait, you already ran it? I didn't know what you ran it already?
Yeah, I checked the answers,
Okay.
and I'm
Wait, so
saying,
you already did 8B?
yeah.
Okay.
Oh, we
Okay.
did.
Okay, that's good. I mean, I mean that. So you got 100% then.
Well, no, we got number 2 wrong.
We got number 2 wrong.
Yeah, we got
Which one?
partial.
Which one?
Number 2. I doesn't
There's
say.
there's 2A, 2B, isn't it?
Yeah, yeah, I know, but it doesn't say which one is wrong.
It doesn't say which one is wrong. Oh, okay. What are the choices for like 2A and 2B or whichever one, you know?
Remember, it's positive. It's positively skewed, approximately skewed, or negatively skewed.
Hmm. Let's think about this then. Try graphing a 23, 24, and then 28, 29. I just want to see those.
20, 22B.
Yeah, let's look at like that one first. Yeah. Okay, so that's what we have, obviously. And then what about the 23, 24?
23, 24. Ah, it's wait.
What is it?
We did put that. We put negatively skewed and approximately skewed.
So that's what you put, and then that's what, why, like right now, like you put that already?
We put dogs as negatively skewed and cats as approximately skewed.
And then what did you have before? Or I
That
don't know.
that's what we had before, but approximately and negatively.
Oh, okay, my good. I guess you could let me see if I can look at
Oh
something
wait,
else.
you said the answer is positively skewed for this one.
Yeah, what did you put?
Negatively.
Yeah, try put positively, yeah.
Okay, hold on. Okay.
Yeah, like positive is like to the left. It's like a wave to the left. Oh,
All right.
negative. Okay.
I have to refill in all these answers, so just give me a second.
All right. I hate those. Okay.
1 is 50, 226.
Make sure you don't screw up because then it doesn't
Oh,
save your.
yeah, 50.
Okay.
3A is mean. 8.6. Question 4 is 1.91. And 5 is 2.3. More than question 7 is 0.011. And 8A, 100. I'm gonna stop sharing my screen real quick.
Okay.
Are you seeing what I'm seeing?
Yeah. So you got what's your what is it? 12? Is that like everything?
So we gotta write a conclusion.
We have to write a conclusion.
Yeah.
What the heck? I didn't know this. Okay. Does it matter? Is it qualitative or does it matter what you conclude?
It, it, has to be in a paragraph.
Okay. Um, let, let me see. Let's try analyzing the data then. So as direct answer to the lab, upload a single document answer to the lab question. The lab question meaning the one up top, right? Compare the weight of the adult cats. How typical would it be to find a 13-pound cat? How typical would it be to find a 13-pound? Using the okay, so your our code. So okay, just use this code that we have.
Yeah.
Any figures you generate, and then in this last section, you will write an upload of answers to the lab question. You will not begin a template like you were in front of it. Instead, use the rubric below to determine what is expected in your answer. Okay, let me look at the rubric again.
The rubric.
Yeah, the criteria at the bottom. Okay, let's see. Answer is well constructed. Grammar. Okay. Shape, center, and spread. Each is accurately described. Ah, my goodness. Okay. And appropriate methods are used to locate a 13-pound cat and a 13-pound dog and their distribution. The likelihood comparison is accurate. Okay, so the main things here are like the second and the third one.
Yes.
Oh
Well,
man,
one
you
through.
wanna you wanna just like I think it'd be nice if you like try it first and then just maybe send it to me and I'll look at it. It's not due until tomorrow, right?
That's not due until Friday,
Oh
technically.
no, not tomorrow, Friday. Yeah. So maybe do you want to just like take a stab at it first?
Yeah,
I think I'll be more effective that way because like you know what I mean, right?
I know how to write a paragraph.
Yeah, just try something out and then like I'll look at it and I'll try assess it from these the rubric.
She made us. She did lab 2 with us and write a paragraph. She wrote a paragraph, so I'm gonna just like copy paste that paragraph and like
Yes, yeah, just do it like that way. Don't reinvent the wheel. Yeah.
I don't want to rewrite it again. So
Okay, and then do you understand the question though?
what question?
The lab question. Like
This
yeah, what is that asking you? Yeah.
compare the weight of adult cats and dogs at the shelter. How typical would it be to find 13-pound cat? What about a 13-pound dog? No, I do not understand that.
Okay. So pretty much like what we already have. Uh,
Hold on.
like just okay.
I'm gonna write this out so I don't forget it.
Okay. Let me just. But then like the way you guys, so she went through one of the labs with you. What was the question kind of similar, or is this like totally different?
Totally different.
Okay.
But
I was thinking like maybe just do something like what you already know.
hold on. Let me see. Recent here. Do you see what I'm saying?
Yeah, I see it. Yeah. So let me see the question in which variable is the strongest
Mhm.
linear. Okay, so this is different. This is about linear regression, or
Yeah.
somewhat. What you have to do here is like kind of like assess the normal distribution, uh, and then let me think how I can better explain this one. Let me see.
So where on here did she answer the live question?
Oh, for this one, okay. Let me just read it again. So, which variable has the strongest linear relationship? The distribution of any of the strikes good. Okay, that's just the first sentence is evidence. There was an outlier. Okay, another evidence. It was a moderate positive. There you go. The third sentence. There was a moderate positive relationship between the earnings and ride percentage. And I
Okay.
guess, and then every time it says that relationship means just look at the you know what that means, right? Like looking at the line. If it's positive or negative, it tells you something about the variables you're comparing. That this one's easy. The other one's a little vague, right? The one that we have is a little vague. Like if it, like how typical, right?
Yeah.
The
That's
first sentence here, compare the weight. You could probably look at that and say, oh, the cats have a high, that's like a number, right? Compare the weight. When and when it's saying that, what tell them write the mean of the cat, and the mean of the dogs, and then the standard deviation. And then, like, just remember the mean is the center, and then the standard deviation is the spread. Like how far away, are the dogs at the shelter or the cats at the shelter? How far away from the mean are they?
Okay.
And what other things can you do? Let me think. And you can say like the percentage of the cats that weigh between like you can test your confidence interval.
Hold on.
You can probably check your p-value. I don't do you know how to do that? Checking your p-value?
Hold on. Hold on. Hold on.
Okay, okay, okay.
I'm gonna do it on the same page here so I can kind of reference it. So you were saying?
So are you ready?
Yeah.
So I would probably report the mean of the weight of the cats and the dogs.
So
Okay.
over here, report the
Yeah.
mean.
We have this already. Like it's all in here.
This.
Yeah. Like it's all in here, yeah. So the cat mean, the dog mean.
Oh wait. I'm just gonna run all of it so that way. There.
Okay.
So the cat mean is 8.6.
Yeah.
So
And then you also need your standard deviation, your spread. And do you remember those histograms?
yeah, these.
So those histograms, we also assessed those, right? Like we said that one of them was approximately normal.
And one was positive.
Yeah, that tells you something. That's the shape. That's like the shape. You have the mean, which is the center, the spread. You need that. You need all three for both the cat and the dog.
Yes.
So I think that checks off like rubric number two. And then like rubric number three. What does it say? Rubric. I think the other one is like, so now what can you say something about the the
Then
data? So you can probably say something about like the which one is this one? The five the
yeah,
quartiles. You can also
yeah.
do that for cat weight. Like we only did it for dog weight. You can also do that for cat weight. You can talk about at the 25% and the 75%,
Okay.
and then maybe say something about let's see, what else can you say? So by reading the standard deviation, like when you have one standard deviation, right? Like the mean plus one standard deviation, um,
Yes.
that tells you something about this. Let me just standard normal distribution percentages. Let's take a look at this.
So for the lab question, uh,
Yeah.
I should put compare the weight of adult cats and dogs at the shelter. How typical would it be to find a 13-pound cat?
So you know
Right.
how like the last question, you see that 8B?
Yeah.
Can I see that? Can you see that the typical the lab question again? I just want to compare it to 8B.
It's the one completely bolded.
Okay, let me see this then. How typical would it be to find a 13-pound cat? Okay, so when you're saying how typical is it, meaning like what's the probability, right?
Yeah.
Like what's the probability it would be for you to find a 13-pound cat? So equals a 13-pound cat. So maybe find that. That should be that's like a I think you can just do If you look at 8B, look at 8B again.
Yeah, I'm
Try
looking.
go back. Yeah. If you go back to 8B, it's kind of related to this question, right?
Is it the print round 1, 13 main to
Yeah,
this?
that one. The one where it's at saying the percentage of adult dogs in the shelter weigh more than 13 pounds. So you can say like, what was the answer to that? It's about like 83%, right? If you run that.
3%.
Yeah. So then it's only 100%. So more there in the shelter, there's 83% adult dogs, right? That's more adult dogs that are more than 13 pounds. So you can also say 17% of the adult dogs weigh under 13 pounds or 13 pounds, right? You can say that one, right? Like
There's some-
17% equal is the probability or the percentage of the adult dogs in the shelter that weigh less than or equal to 13 pounds. 17, 1 7. Yeah. Because like if the answer to the adult dogs weigh more than 13 pounds is 83%, you can say 17% of them uh, would be 13 pounds or less.
Yeah.
And then like if you look at problem 7, um, that one's just for the cats one, right?
Yeah.
So what was the answer for that one? Like we said like 11%, no, 1.1% weigh more than 13 pounds.
Yeah, it was like zero. It was 0.011%.
So the converse of that is the less than or equal to 13 pounds. So that's like what, 98.9. 98.9% of adult cats would be 13 pounds or less.
%98 or 80.
You can just round it. It doesn't matter. 98%. Or like 99 rather. I think you should put 99 because it's like 1.1. So this is pretty much the question, and then the comparing would be the numbers and the shape of your graph. And then, after this, I would just expand on it. What does this mean?
Yeah, and then you talk about um, this, or that's not it. This.
Yeah. And so like the methods, it says there number 3 in the methods. I would just talk about it just so that you get full credit. It says that appropriate methods are used to locate and then right. So just talk about, I mean, you're gonna include the code, but then just talk about how you got the answer.
So in the distribution, right? We're talking about
Yeah,
distribution. Um, right, we're looking at 8B, right?
8B, yeah. Or like 8B and C. 8B and 7, I meant 8B and 7. 7 is the cats, 8B is for the dogs. Yeah, you could actually just refer to it if you wanted to. But like I think to sound you know how she wrote hers? This is hers right up top. Kind of like make it like that. Like kind of like, okay, I tell you my conclusion, but then now let me support it. So
There was a It was positive. It was a positive. There was a positive.
There's no relationship in this one because we're only talking. It's not linear regression. We're only talking about the normal distribution.
So it
So
was two and more, right?
so like what I would probably say is so looking at 17% and 99%, right? You're looking at these two guys, right?
Yeah.
Which one do you like if you were like randomly going to a shelter and you went to the shelter and then like randomly you pick a pet, um, which one is the what do you think would be the likelihood of you getting a cat versus a dog? It would be a higher likelihood, right?
Yeah.
It's 99%. So I would probably say that like there's a higher, if someone ran, I would say the likelihood of me or anyone um of getting an adult cat that's like 13 pounds would then be higher, would be higher. The likelihood of getting a cat is higher. You could say is higher, or that is at 30 pounds is higher than the likelihood of getting a dog. And just fix, how it sounds. This is like the gist of it. And you could also say the converse. So you can say like the likelihood of getting, you just pretty much explain it. The likelihood of getting a dog is lower than getting a cat. She wants you to or like to talk about these likelihoods. Likelihood is just another way of talking about the percentage. And then I guess after this you could talk about the percentiles. So the five num. So you can say like where does the 13-pound lie? Is that 25% of the population of the cats, of the adult cats or dogs? So like the same way as what you did here, where you said like in the data there's 17 and 99. Try talk about like the amount of adult dogs that are 13 pounds lies. So do the five num. Try to look at the five num of the dog weight and the cat weight
Yeah. It was 20. It was 25% was.
of the population of adult, or was just in the amount of dog in the amount of adult dogs. There are 25% that are 13 pounds, or there's 25% that weigh 13 pounds. And then like, you could do this for the cat one. I don't know what the answer is for that.
How would you do the cat one?
You just do the same thing as what you did in 8A, the five num.
But you do it for cat.
Yeah, try doing that one. I didn't do that one. That wasn't a question, but you could do that one.
Cat weight. Yeah. That is an option.
And I think after this one, yeah, that's pretty much it. I mean, that there's nothing else you can say. Oh yeah, you could pretty much yeah, obviously put in the shape of each one of those like histograms and then the mean and the standard deviation and then that's it.
Uh,
Like
well, she'll run the code.
now she's just gonna run the code.
Yeah, yeah, yeah. She'll just run the. So when you submit it, she'll just run the code.
Okay, that's good. But for the conclusion, like I think this is good enough. Just put in the like the comparison of the weight in terms of like the shape. Actually, yeah, this is good already. After this, you could probably just send it. Just pepper it a little bit, and I think we're good to go. You don't have to send this to me. I think it's already good.
You want me to send this to you?
You don't have to. I'm reading it now. It's pretty much good. The only thing is, at the beginning of this paragraph, just put in like the shape of the cat and then the dog weight, the shape of each of the histograms, the mean and the standard deviation.
The the it was positively and negative and
Yeah,
approximately.
exactly. Yeah, just put those three things for both the cat and the dog, and then that's it. Yeah, like that's all you have to say. It's just compare. And then they want you to, you know, put the actual values explicitly. Apparently, approximately.
And then I just have to put the whatever the actual answers in there. Well, we kind of already did.
Yeah, what you have is good.
Okay. Thank you, Paul.
Yeah, man. That's what do you think of that? Do you understand it better?
Bit. I'm still having trouble during class coding.
Okay. What I'm thinking, like a lot of these, I guess my first suggestion is just do the code like the way, I mean, I know it's gonna be tough a little bit to just like base it off like, how we're doing it from the way I'm coding it. But I think you'll just learn if you try to like redo my code and understand like all those, all those commands that we talked about.
Okay.
And then like, yeah, for the next ones, yeah, definitely, I'm willing to help you out on all of them. I like doing this kind of stuff, R coding and then just statistics. Yeah, so yeah, if you want, just send me your next ones and we can do this again.
Okay. It's so sad. I had my uh, what was it called? The assignment we did today up that you since it's the UT camp the university thing. I
Yeah.
can't go back to it, but my power like shut down today. I was
Um,
gonna go over that, but that's a bust.
okay, just show it to me. Well, whenever you get a chance, and then like I should be able to help you with that. When do you guys have your next lab or like your next assignment?
They so they have so with like the accommodations I get for the class,
Yeah.
I'm excused on the reading part of it.
Okay.
Um, so I think I was doing this instead of the
Which one?
reading homework.
Oh, there's a reading homework.
Yeah, but I'm saying I was doing this instead of.
Okay. Should we do that then as well? Should we do the reading homework?
No, I don't have to do it.
Oh, you know, okay, good. That's fine. Okay. What about the next? Do you guys have other things next week?
We probably do.
Okay.
I'll let you know. I am
Yeah.
not aware
Okay.
of this moment.
Okay. Yeah. Like I said, like if you have, cause like yeah, the pre-lab 1 and 2, those things like I was looking at it, like those like somewhat like I don't know if you guys will go. Oh, you probably will, cause like this is at the beginning, but like getting those like concepts, graphs, would be great. Just knowing the
I can
basics
work
of.
that out with my teacher. I can see if that's possible.
Okay. Yeah. If you can do that, that'd be great. That'll be more
It'd
stuff
be
for us to
easier
review.
for us.
Yeah. Okay. All right, Parker. I have another appointment, but yeah, let's talk again once you get like another assignment or lab.
Yeah, for sure. I'll
Good.
let
I
you.
meant
I'll keep you up to
have a
date.
good one. Cool.